Please introduce yourself and briefly summarize your education and professional background.
My name is René Morkos. I'm a second generation civil engineer. When I graduated high school, my dad gave me a good piece of advice. He said, study anything you want, just don't do civil engineering. It's like, great. I know what I'm doing with the rest of my life. I like to build stuff. You name it, I built underwater pipelines in Beirut, $350 million gas refiners in Abu Dhabi. Spent a year in Afghanistan as a civilian private contractor, helping with the reconstruction of the country. Ended up doing a PhD at Stanford, did my PhD in AI applications for construction, and also became a lecturer. So I co-teach the main construction management class at Stanford. And I founded a company called Alice Technologies, which has developed the world's first generative construction simulator. That's what I do.
Okay, so you mentioned some of these, but when and why did you find Alice Technologies? Could you describe some of the backstory and what was there an industry gap that you saw that you thought you could fill?
90% of construction projects are behind schedule or over budget. And the reason is that you got 10% of world GDP. That's what construction represents, believe it or not. $14 trillion a year worth of construction is managed with Gantt charts. Those Gantt charts suck. They're manual, they're tedious. You got to create a list of tasks, manually draw them, link them, etc., etc. And when I was in Afghanistan, I was building these landing strips for F-16s, and I was trying to figure out the optimal sequencing. And I couldn't, like, it was, crazy location, but a simple project, right? And I couldn't figure out the optimal way to do it. So I kept thinking, like, I want to go find the tool that does this. And I end up finding it, so I end up building it. And so Alice is the first tool that enables you to take a construction project and then build it for you tens of different ways. You can simply add a crane, rebuild it. There's a delay, resequence it. Try different production rates over time. Like you can tweak parameters and the software will rebuild it. And you can either use a 1D version, so just ingest an existing schedule, optimize it. There's a 2D version where you can visualize the 2D. And then there's a 3D version where you can use a BIM model and use that as a basis. And you can kind of switch back and forth between them.
Why do you think that having the multiple like the 2D, 1D versions is a positive? Because most of the schedule models I've seen, they highly tout the fact that they're 3D, 4D. Is it having the variety? Do you need it simpler is better for some projects, or can you explain that a little bit, please?
We started by building a 3D version. So that's a great question. There's two reasons that you want to use 1D or 2D. And the first one is you don't always have a 3D model. Truth be told, like even projects that want to develop a 3D model early in the process might not have one. We're still in design phase. We're still in pre-construction. Like we haven't built out the 3D, like whatever the reason is, right? Or we don't want to. We just don't ever want to do 3D. And so that's one. Two, a lot of times if you come to projects already in flight, they have a schedule. So, what you want to be able to do is work with teams that either don't yet have a 3D model. You want to work with teams that don't want a 3D model. And you want to work with teams that want to just use an existing schedule. And so for these reasons, we have a 1D, 2D, 3D sort of what we call multimodal um, approach.
Can you describe a little bit of like perhaps a case example? I know it's tough to describe with words, and that video demonstration would be better. But can you briefly kind of describe how it works, particularly the 1D and 2D versions that I'm not as familiar with?
Yeah. So let's assume that I come to you and you are Bob the Builder, and you're on a project. That's whatever, call it $350 million infrastructure job or oil and gas job or whatever the heck it is. And you have a schedule. You have a P6 schedule. You're happy with it. You're unhappy that your project seems to be delayed. And so when I come to you, if I tell you, hey, Bob, you've got to go create a 3D and then upload that 3D into Alice, set up the constraints and run it, and that's going to take you a couple of weeks, you're probably going to say, well, Renee, like, I don't know if I want to create a 3D model and spend 2 weeks setting this up. Now I can come to you and just say, hey, give me your P6, give me 30 minutes, put it through my system, analyze it, check for constraints that are being violated, collect those constraints, give it back to, run those optimizations and give it back to you. That's basically what we can do. That's what we call 1D, which is a different way to think about it is taking the power of the AI based scheduling and then integrating it into existing systems. That's basically what we're able to do.
Okay, since you brought up the AI aspect, can you talk a little bit about how that works and how that is built into your products and what is it doing?
There's a number of different ways that we're using AI. And so I think the first simplest way is you take a schedule, you're able to rapidly resolve constraints, optimize for for those constraints, and tweak those, parameters. So you can add cranes, add crews, resequence, like you can run multiple scheduling iterations. So that's one way of using AI. Another way of using AI is that we have what we call spatial AI. And so our algorithms are aware of concepts such as proximity or sequence. And so, for example, if you bring in a 2D or a 3D model and the software resequences it, it will actually take into account where those tasks are in space, right? It's a phenomenally complicated problem to solve. Um, Fei Li, one of the sort of, they call her the godmother of AI, just raised 200, I think $60 million to solve for spatial AI. And I can see why we solved a couple of it for Alice. So we have the spatial AI aspect. And then the last piece of it is we have a natural language interface, or think of a large language model that you can query an existing data set. So, one of the challenges of schedule is they're, 3,000, 6,000, 12,000 activities long. So how do you make sense of it? And so for us, what we're able to do is we're able to take that schedule and basically enable you to ask questions, and it will answer those questions for you in real time. It will give you insights into the data.
All right, I wanted to follow up on another thing on what you talked about with the Bob the Builder 1D example. So what would, if he gives you what he's got and you turn that around for him, what exactly are you giving him in the 1D world that he can use and how is he applying that to his project?
You're on an infrastructure job. Let's say it's I don't know, 20-kilometer highway or something, and it's $100 million. The job is currently delayed. And so you're trying to think of yourself, okay, well, maybe if I change, a piling sequence for the bridge section, or maybe if I change the number of crews that are available, what if I try overtime? Where should I do the overtime? Is it for everybody? Are there specific crews? Maybe I can get away with a little bit of overtime at specific crews or specific times. That's what else will do for you, like bread and butter, right? That's falling off a log. Run those analyses, run those simulations, and figure that out. Um, Data center project, right? How can you better sequence your electricians to save 35 days? We've done that. Um, a commercial mid-rise, I think 15 or 20 stories. What we figured out is that the owner said, hey, the permitting is going to be 2 months late. And then the contractor said, well, on top of it, we think our drywall production rates are going to be half as fast, right? So then the question becomes, oh, shoot, we're 2 months late on the permitting, and now we've got a production rate, hit. And so how do you recover from that? And the way we did it is we said, okay, instead of doing the interior work floor by floor, unlock that constraint, let the software shuffle between floors, right, within some three floor limit, right? But doing that actually saved, I think it was like 45 days of that 60-day delay. Those are several specific examples. Let me know if you want me to go into
No, I'm
more.
kind of like, so you're giving them basically the timeline model. So I guess I'm trying to understand what it looks like on a 1D thing that they're looking at to do their descriptions. Is basically is that text? Is that engineering drawings? What are they looking at to make their decision? Or just a computer interface?
Yeah. So you basically ingest a schedule. And once you ingest your schedule, it's your schedule, your cost codes, your WBS, all of that stuff, right? And then, so this is your schedule, right? Once you ingest it, you can then you can go to explore. And this is sort of the big deal, is this is your imported schedule. So we started off at wherever that diamond is, right? So you isolate it. So your schedule originally was 1,249 calendar days. And so the first thing is we actually corrected those, checked for constraint resolution. Are there any constraint and missing or erroneous constraints? And the answer is no. In this schedule, your constraints are actually correct. That's a good thing to know. Then we tried, well, what if we have realistic labor resources over time, right? So what you're saying here is that basically, That's overtime has now reduced my schedule from 1,249 to 808. We tried realistic labor, we tried adding, shuffling resources between tasks to some, not adding resources to the project, but moving resources between tasks, right? There's an unexpected labor restriction, and that pushed us back out, right? And then you can kind of see here parametric excavation. So we then actually added production rates to these tasks and made sure that was it. Now we've got available resources. That means basically what we've done is we said, hey, these are the available resources on site. Model that for me. And then what you'll see here is available labor resources. So I don't know what they did here, but they did overtime, 4 hours of overtime for tunneling, right? And then now they started resequencing, right? So what you're seeing here is that for each one of these simulations or simulation runs, you're seeing the results, right? You're seeing the ability to like click on this and say, okay, um, you know, analyze solution. You're kind of seeing on the cost time graph what the impact of your decisions is, and then you can export the schedule that pertains to that simulation run. And whenever this loads, what you'll be able to see is your schedule basically optimized. Does that answer the question?
It does. No, seeing that helped a lot. So the program's kind of optimizing the schedule, giving you the options to say, hey, this is what it looks like. And then once you can kind of click on the option you think is best, it goes into a step by step in detail of how it got to there.
Yeah. Well, I mean, what it does is it gives you the schedule based on the parametric changes that you've done, right? So you've gone in here, you said, hey, I want to add cranes, I want to add crews, and automatically reschedules it for you, produces a new schedule. So now you can analyze, okay, this is a new schedule. You can also do, by the way, is you can sort of click on this, compare, and then say, well, okay, this option here, right, was when I resequenced the drilling piles. Soft logic removed is resequencing, right? And then for this guy here, what I'm going to do is I'm going to say, you know, now I can basically, click on that, compare. And what I can do is I can look at the overview of what the difference between those schedules is, right?
Okay, and then I guess if they find out that something that was recommended by the program just isn't, going to be feasible, they can just
Yeah,
eliminate that and see what's left.
exactly. You go back in there, tweak it. Like imagine the cost of exploring an option is zero.
Hmm.
Imagine you could build it 50 times before you build it.
I've just got a couple more questions I want to follow up. So our audience is probably less of the construction and the builders and the owners. They're more the civil and structural engineers like yourselves. How would you recommend that they kind of adapt and use to, 1D, 2D, 3D, a 4D? What's some advice on what they should try? Should they try them all and see what's best? Do they look at it project by project? Do they try and get an expertise in a couple of them and stay there? What
Yeah.
kind of advice would you give them?
What we've learned is don't tell our clients how to run their business. What I mean by that is that, you asked me for what advice would I have. The advice is stick to what you're doing. And so what I mean by that is that if you're someone that's saying, hey, I'm actually creating 3D models and I use those for construction and I use those to like for quantity takeoffs and that's what I'm doing, great. That's the direction you should head in, right? Um, if you're saying, hey, I just do schedules. Like I don't connect them to anything else. I create schedules and that's it. I really don't care about 2D or I don't care about connecting the schedule to other information. It's a static standalone system. Great, stick to that, right? Um, I wouldn't recommend integrating beyond what you're currently doing, right? Take what you're doing, automate and optimize it using AI or algorithms, let's just call it that, because AI is such an overused term these days. Optimize your existing workflow using some software. That's where I would start. And once you've got that going, then ask yourself, hey, is it worth my time to maybe tweak an existing workflow a little bit so I can use a different software or a different part of the existing software? That would be my advice.
Okay, that's great. I really like that. In addition, an important part, and I think that engineers are coming around very quickly, is how important scheduling is to design now, rather than just creating models and making sure that the schedule is in there from the original design. What are your thoughts and advice again, and how important scheduling is, how quickly they need to get into their process, and maybe some tips if they're not as focused on scheduling as they are now that they should be doing?
I would start with a question, and the question is, what is construction? Construction is fundamentally taking a scope or a design and converting that scope into a list of who does what, when, and where to build it. That is construction. That is how you build. And so the reason that's significant is that um, when you are in in the business of delivering a project, designing, building project, a schedule is a fundamental part of that. And so as you're doing it, right, um, it makes sense to think about the scheduling aspect of it as you're building it. And so, especially when we talk to like design build firms, um, taking the design into account as you're doing the construction schedule um, is has always been a good idea, right? Whether you're doing it directly from the model or you're using the quantities to inform the durations of production rates. And those are sort of the two ways we've seen it being done. You either create the 3D model of what you're building and then you use that with Alice to actually run the simulations or run the actual schedule, or you're creating the schedule by yourself, but you're connecting it to your QTO. You want your durations of your tasks to be connected to the quantities so that the duration is actually effectively, tied to what you're building.
So would you suggest that they need to kind of make sure that they're thinking about, not just them as engineers making a cool design, but looking at each project as a construction project first, so that they can look at the whole thing at the same time, and that their design is just a piece of it, just it's to accomplish the construction project. Is that correct?
Yeah, I think like, for example, when you're creating 3D models, not drawing a column that spans 5 floors, right? Splitting that column up. We're thinking in terms of, hey, it's one large floor. Maybe I can call the construction engineers that are on the job or the GC and say, hey, are you guys building it in one piece or are you splitting the slab into two, right? Or how do you actually want to sequence the job or how do you want to think about sequencing the job, right? And so that's this kind of stuff that you can think about as you're building the design that helps or aids the construction down the line.
Okay, so taking some of the things we've talked about, if someone has a small engineering firm that they're, kind of building and starting up, and what kind of advice to kind of explain that they do these things to help them get more work, more design projects? How can they kind of sell to those people, paying for their services that they do this and that it's important?
Our industry has definitely seen the integration of design and build and how beneficial that is. I don't have the statistics off the top of my head, right? But um, anytime you bring the builders in earlier into the design process or early into the project lifecycle, you see advantages. You see advantages because you can tweak the design, you can tweak, construction. The level of influence is highest earlier in the job. But like decisions that you make early in the life cycle have an outsized impact and they cost the least. Once you're halfway through construction, the level of influence is smaller. So as you progress through the job, I think it's called a Marshall graph, but I might be mistaken. But as you progress through a job, your level of influence decreases and the cost of decisions increases. So halfway through construction is usually very difficult to tweak the design, right? So for example, if your facade is not of the optimal type for the construction project you're building, it's too late to do anything about it, right? Or if you could change, the cantilever on the second floor to be a little bit shorter, it would totally change the type of formwork that you needed. Those are the kind of decisions that you can make and save time. Um, Oftentimes we've seen that very successful when there's a either design build contract or a joint pool for value engineering. So those are the conditions under which we've seen this effectively motivate people to bring construction earlier or unite engineering and construction.
How about perhaps some best practices on how to get the builders involved early? Is that in the contracting before you even get started, or is that once you've got in place, making sure you have those meetings early on with the build side?
I think that the contract type that you have dictates a lot, whether it's design build, right? Um, I think another is the owner level of owner sophistication, right? So there's some owners that just they don't care. They view it as a lump sum project, and they're like, "This is not my headache. You guys figure it out," right? Um, a lot of owners are sophisticated enough to be like, okay, well, how can I help build value throughout the process and instill value engineering culture into the project delivery team. Right.
Do you learn how to know which kind of project owner you're working with? Is that just from experience, or is that kind of some kind of evaluation to know what you're dealing with and what the best approach is?
Yeah, I think that for us, like I can tell within 5 minutes of talking to someone which bucket they fall into, and I think the easiest way to tell is to ask yourself a question as you're talking to them, which is, are they in the business of solving problems or outsourcing headaches? And that is something that is, it's literally not even 5 minutes. Within 3 minutes of a conversation, you know exactly what it is. Because they're either saying, well, they're backpedaling. Well, we don't really sort of think about the control. Oh, we don't really do scheduling, and that's kind of the GC's job. And like, yeah, maybe the subs, like, we don't really think it. That's not our worry. It's not, you'll start seeing these sort of hedging sentences versus yeah, this sounds really good. We definitely have issues on X number of projects that we're managing. We've seen delays on these conditions. We've been working on fill in the blank kind of initiative for supply chain, or we've noticed that the problem is in Y or Z, or those are the sort of phrases that you'll hear from an owner, versus, well, it's not, we'll kick this can around and figure it out later. From our perspective, we just launched Alice Plan, our 2D version of software, which is uh, like it's almost for everyone everywhere in the sense that it's so easy to use. Planning has always been visual, and now you have a way to connect that 2D to your schedule and view it in 2D and resequence in 2D. So what's really, really cool is you can actually draw arrows from groups to groups of tasks, like three arrows from 100 to 100, a group of 100 to group of 100 to group of 100. The software will automatically resequence it for you, which we think is like super powerful and very cool.
That sounds great. Was that what the what you were demonstrating for me on the quick screen share?
And that was the 1D version, right? But I'm happy to show you the 2D if you just want to sneak peek. You got your schedule, right? What you can now do is we want to pull in the quantity takeoffs from your, estimates, and then basically, drag a schedule. Now your schedule on the left side, plans on the right side, and then you create new blocks. Now you got your blocks. These are groups of tasks, and what's really cool is that you can now draw an arrow from this group to this group to this group, and it just literally figures everything out for you. This could be 1,000 tasks, 1,000 tasks, and it will resequence it all for you. And then you can redraw the arrows and see like visually. And then there's a time lapse. You can actually watch this thing get built, right? I don't know if you've got it in here, but it's maybe an older video, but you'll hit play and it'll actually show you how your work is progressing on site.